Hi guys, I'm Sunday Sylvester Nasa, and in this video we'll be discussing on nature of matter, separation techniques as well. So this topic will blast in now. Okay, these are our content that we're going to run into them. We quickly go into it and we'll study. First, definition of matter, properties of matter, physical and chemical change. The change in state triangle, I'll explain that one, element, compound, and mixture. Then these separation techniques here, sieving, magnetic, sublimation, decantation, filtration, centrifugation, flotation, evaporation, crystallization, can be fractional crystallization as well, precipitation, distillation, and fractional distillation, separation funnel, separating funnel, and chromatography. Here we have separating salt, sand, and sodium chloride. I'm going to discuss on this because John really like asking these ones. We're going to talk about impurity, tests of purity, and also purification. So that's what we're going to be doing. So first, definition of matter. We like to start with the easy thing so that everybody will flow with us. So we define matter first. Matter is everything that have mass and occupy space. Well, everybody is cool that one. I'm not gonna waste time on that one because I just want to lay foundation. Everybody knows that one. Next one is properties of matter. Okay. Matter is anything that have mass and occupy space. So what are the properties that you'll be able to detect and say this thing is actually a matter? There are two things. The first one is actually the physical properties, and the second one is the chemical properties. There are two different things. I'm going to discuss on them now. So the physical properties, these are actually properties of matter. So properties of matter. So the first one, it can be physical. Can be physical properties. So how do you detect physical properties? How can you tell which one is physical properties, which one is chemical properties? Well, physical properties are the ones that are much you can detect them with plenty things. Most especially, let's go with your sense of organs, right? Your five sense of organs. You can remember there's 6 or 5. So you have your ear, your nose, your eye, your skin, the touch. So all of those guys are actually your sense of organs, and you use them to detect like the sound. You can use them to detect the sound. So if you hear a voice, it's actually a physical, how something is cracking or how something is reacting, a convulsion, like all of those things are actually physical properties. So the sound, the smell like the odor, right? The odor of that thing, like tastes sweet, tastes like ammonia, bad taste like that. All of those guys are actually physical properties. We also have like touch your skin. You touch, yeah. If you touch something, look hard, like stone is actually physical properties. If you touch something like water, liquid water, it look, yeah, is is okay, yeah, okay. Touch, okay. If you touch something like, sorry for making that. If you touch something like water and you feel like more is kind of like liquid, you touch something that is gas, yeah, you can even feel it. You can be saying a lot of things just by touch. You also see some things. You see colors. You see colors. Seeing this, you can see shape. You can see color. All of those guys are actual physical properties as well. So anything you can detect with those guys are actually physical properties. So if they give you an equation and they were asking you to dictate to say which one is actually physical properties, which is chemical properties, you can easily remember it by this chance, right? Your physical properties are the ones you can detect them with your sense of organs. And there are other couples of examples that you can still dictate with physical properties. Yeah, they are not really in the sense of organs, but shall let's go with it. Like with the boiling point, the boiling point, the melting point. You know, boiling point and melting point are always together. Boiling point and melting points. Uh, as well, we have density. We have density and also the acidity, like the pH. You can go with it, the pH. So once you know these ones, I think you're cool with it. Because these are the physical properties. Next one is chemical properties. Chemical properties. Okay. Chemical properties are the properties that you will be able to sense them when you react things together, right? When you react two things together and they form a special things. For example, let's say salt, kind of like is evolved or is produced when acid and base react. So if you react something with a base, you're sure of this thing is actually a base, and you react something with like unknown thing with that with the base, and you form salt and water, you can conclude that that thing is actually an acid. So those are actually chemical properties that is always there for it. So chemical properties is actually the properties that has to do with reactions, yeah, right? It has to do with chemical reactions. All of these equations that you are forming, like you react an acid plus the base, let's say NaOH, right? To form something different, like you form the salt and water. You understand these things? So this is actually like when this thing reacts with this thing to form this thing, this is actually this reaction is actually chemical properties of this one. And this reaction is also the chemical properties of this one as well. And as well, this product is actually a chemical reaction of the chemical properties of this reaction. Because if this reaction occurs, that's what you're going to form there. There's not much things to discuss on those things, but I think this is clear. So the next thing is actual physical and chemical change, right? What is change? Changes, right? Okay. Change is actually, we have different states, right? Of matter. We have different way you can get the matter, like the sound, the smell, the touch, you feel like the pH, the density, you can increase them, you can change them, right? So the change, when we increase it and it change from this point to this one, there are some of the changes that actually are typically physical changes, that is just within these guys, and there are changes that are actually chemical changes that's within these guys. So physical change are changes that occurs when you have changes within these physical properties. Another simple way of defining it, the way everybody likes it, is actually a changes that is actually reversible. It's easily reversible by like a physical separation techniques like these ones. For example, uh, let's say this water, and I cool it and make an ice. You can see this water is actually in liquid form, and when I cool it, I make it an ice and it turns solid. So if I touch this one, I feel liquid. If I touch this one, I feel solid. But the truth is that both of them are actually H2O. You can see it? Both of them are H2O. So this is actually a physical property because we just changed the physical. This is actually a physical change because we just changed the physical properties, right, from liquid to solid, right? Um, when I react, uh, uh, let's say water. When I react water and let's say acid. Let's say I react water and concentrated acid. So what I will form is actually a dilute acid. What I mean is that if you put water inside acid, the acid will still remain there. Let's say it's actually HCl, right? Concentrated HCl. You still produce concentrated HCl, but with very, very low pH, very, very high pH, let me say, in terms of acidity, so that the pH will go towards 7, right? Let's say hydrochloric acid, most of times they're in 2, right? So it will increase, the water will increase the pH to somewhere like, let's say it's 5. So it becomes less acidic, right? Or more dilute, right? So you can be using it in your lab, but it's still the HCl, citric acid. So what I'm trying to say is that when you actually react water and concentrated acid, or let me say you put water and concentrated acid, you don't form new thing. You still form a hydrochloric acid. You still form the acid, but it just dilutes. So So it's just the pH you're affecting here. It's just the pH that is affected here. This is also a physical changes here. So a chemical change. There are some reactions that if you actually react them, you form nutrients. For example, when you react water, when you react water plus let's say a metal, like let's say sodium, uh, let's say sodium oxide, you form sodium hydroxide, right? When you react water and sodium oxide, you form sodium hydroxide here. So you can see that I'm reacting different in here, but I'm producing quite very different elements here. Also, let's say I'm reacting sodium and chlorine, and I'm forming sodium chloride. You know what? Sodium here is actually a metal, a very reactive metal. Like if you bring it out outside in your lab, because it will start combusting, right? Reacting with atmospheric oxygen and causing a like spark like this. Like it will be catching fire. Like it's very active. But chlorine as well is very like yeah, it's not that much reactive. It doesn't react with oxygen and air, but if you take it, it's very harmful. It can kill you, right? Chlorine is actually a poisonous gas. But if you react sodium, this white matte element here, matte metal here, with this wicked non-metal here, they form this useful thing here, like useful thing we call salt. Every day you have to put it inside your soup to you take it. So look at what happened. You're reacting harmful thing, and produce new different thing that is you're totally depending on. That's the sodium chloride. Man, this is actually a chemical change because you are forming entirely different thing here. I believe you're making sense of this things, right? One thing I want you to understand with this topic is that I'm apologizing because this is actually terrible. This topic, I think, if I were to like design my textbook myself, I will put this topic at the back of the textbook, like until you're done with the understanding of very good foundation of chemistry before you study this topic. Most especially if you come to separation techniques, you'll see a lot of problems there. So I'm making this reaction as an introduction to chemistry, and I'm making these weird reactions here. But if you study metals and their compounds, all of these topics gradually, you have good understanding, you flow with me. So if I'm doing anything here, it sounds confusing, it sounds like cram, you have to cram it, don't just, if you're not understanding, like you are understanding, but you have hard time to grab them or hard time to remember them, don't disturb yourself, right? Just leave it and continue learning your chemistry. With time, when we are done with most of the topics in chemistry, if you come to this topic, you find it very easy, right? Most especially acrylic. I said if you study metal and their properties and non-metal and their properties, if you study them very well and you're done with them with some relevant topics, if you come back to this topic, you find it very easy, right? So let's just go with it like that because yeah, there are weird things here. Okay, that's a chemical change and that's physical change. And there are kind of like a list of them, right? There are a list of them, and there are plenty. Hmm? And I think I recommend when we finish those topics, you will understand it because if I'm giving you the list now, it will be as if you're cramming them. But there are some important ones that let me mention them because so that will flow them. They used to ask them, right? So the first one, let me mention the physical properties, right? Physical change, right? I'm making this sign. I don't want to waste things here. So example of physical change, I mean the one that is not changing, right? Example, the most common one is change of state, right? Change, change of state, right? Like state of matter. I don't really have to waste time here, right? Because all of these guys is actually talking about this thing, right? So change of state, change of pH, change of like the smell, the everything here. If you're changing them, it's actually physical change, right? And you should know that uh, when you actually react like um, Which example should I give here? Most of this is actually past questions, right? If you go to past question, we'll be seeing them clear. Yeah. If we go to past question, we'll be seeing them clear. For chemical change, a good example there is when you are reacting. They love asking this thing. Uh this lime, some people call it quick lime. Both of them is actually name. When you react quick lime with water, you form something different. Like you form slime lime, right? So this is calcium hydroxide, right? You form something like this. See, this actually completely different between from these two guys here. So you can see we've been adding water, add water. We'll still be mentioning them under physical change because the water is just like it's diluting it. But you can see in some cases the water is actually reacting with it to produce something different. So that's why I say like understanding deep chemistry will help you know it. Because if you want to be cramming, guy, you will suffer. So let's leave it out. We can go to the next thing here. So change instead of matter using our triangle, right? Okay, this is my big triangle here. Let's do it. Let's say this side is our solid side. It's very important to know. This is our liquid. I believe some past question you will see a triangle like this. This is our gas here, right? So when solid is changing to liquid, right? When solid is changing to liquid, then we put the arrow this way. When solid is changing to, let me put the arrow like this because I have two arrows, right? Whether it's going there or coming back, right? So let's say it's going here through this place and it's coming back through this place, right? And put it outside so that I can have good space. Yeah. So when solid is changing to liquid, what was it? What's the name of it? Melting. Please, these are actually things you are used to, right? Melting, right? This is melting. So when liquid is changing back to solids, what's it? The solidification what? It's actually freezing, right? Freezing, yeah. Free, freezing, right? Okay. Now let's say from liquid to gas. From liquid to gas. What's it called? From liquid changing to gas is evaporation, right? It's evaporating, right? Evaporation, right? Well, from gas when you're turning back to liquid, it's turning back to liquid. It's condensation. Before, if rain want to fall, rain the water there is actually in gas form, so it condense, right? So this condensation. You can I write this? Let me just write it straightforward like this. Condensation, right? Okay, this is another weird one here. If solid is changing to, when solid is actually changing to gas, what's it called? This is actually a very common one in your jam. If you are answering question, you'll be seeing this because they're not bothering themselves with this one. So everybody know it. So they want to ask something new. So this sublimation, right? And there's a name for when it's coming back from gas to this. Some people will say it's actually sublimation as well. Or there is another name for it, like deposition, right? There are other name for it, but you don't really need to know. The main thing you need to know about jam is actually sublimation from solid to gas. So when it's actually an ice, it goes to liquid like water. It's just melting. So when you put your water inside fridge, you are freezing it to get your solid, right? While when you are kind of like boiling your water, you're evaporating it to get your gas. When the rain is want to fall, it condenses to get the liquid, right? And there are some special mad elements, components, that you can never meet them in their liquid form. They move directly from solid to gas, from gas to solid. So you can never drink them in your life. That's it. They just have that promise to human beings. So let's go with it. Those are the examples. Examples are cool. The ones you need to know is actually iodine. Iodine, that's I2. It's actually a purple. At room temperature is solid. So if you're heating it certain temperature, the iodine will just start evaporating. You will never meet it melting. It will never melt in its life. Iodine does it. Ammonium chloride and H4Cl does it. Ammonium chloride does it. Because if you are heating this thing will decompose to gas directly. You get it. NH4Cl. If you study chemistry high, you understand what I mean. So if you are heating this, you form ammonia and uh, you form hydrochloric acid. If you're heating this, hydrochloric acid is actually in gas form, right? It's actually a dilute one that is the acid. So you form something like this. So both of them, ammonia, and those guys are gas, while this guy is solid. So that's it. So same thing happened with this guy. You know, the other examples, very, very common. You know, CO2. The common name for it is actually dry gas. It's actually CO2. When you cool it, you form solid CO2. It's actually white in color. Carbon dioxide, the one you breathe out, you form solid of it. But if you are kind of heating it, it will move directly to gas. It doesn't kind of like goes on liquid. It doesn't form liquid. You don't form the liquid. Naphthalene, comfort, all of those guys are actually some of the example of them. But these two are the main ones that JAM normally used to ask. And you will be seeing ammonium chloride there. Okay, that's all for sublimation and everything here. Let's go to the next thing. That's separation techniques. So separation techniques, we say, is the techniques we use. Oh, we skip one. Elements, compound, and mixture first before we go to separation techniques, right? Thank you. Elements, compound, and mixture. So what's an element? An element is actually any substance that cannot be further split down into simpler units. While a compound is any substance that has kind of like two or more elements chemically bonded. I'm actually mentioning some important things inside. And a mixture is actually comprising of two or more compounds that are not chemically bonding together. So I actually define them all of them at once here, not to confuse, but because I want to start explaining from mixture going down to elements. That's why I brush all of them at once. So mixture. What's mixture? Mixture, we say, is actually two or more compounds that are not chemically bonded together, right? For example, when you have a solution, you have solution, let's say Ag NO3 aqueous. So it's solution of this guy. So there is water inside this one, right? When you actually heat this guy, when you heat this guy to like most of the water to evaporate, you find AgNO3. Let's say crystallization. It does it and you form this. When you actually heat this guy to the point this guy will decompose, you form AgNO2 plus O2 here. So this is a reaction you form on them. I'm trying to explain things here. That's why I'm giving this reaction. So this is actually a mixture because it comprises of this one and also water. There is water inside. If you see this one, aqueous is actually comprises of some water. It's actually solution, right? So this is actually a mixture because this silver nitride is not actually chemically bonded with the water. The water is still in its body. You can remove the water easily. While in this place here, the silver nitride is not bonding to water. It's actually pure. So it's actually a compound. And you can see it's two or more elements Yeah, we have more than two, right? We have about three elements, right? Chemically bonded together. So they are compound, right? But here you can see we have an element because it's actually only silver there. So you can never further break this. You can break this ones, you can break this ones because there are still two or more. You understand, right? This is two, this is about three of them, right? One nitrogen and two oxygen. You can still break this thing, you can still break this thing, but you can never break this thing. That's why you define elements as any substance that can never further divided into simpler units. That's elements, and that's mixture, and that's compound. So compounds are chemically bonded, while mixture, they are just physically bonded together. That means they are not chemically bonded. And we say anything that is not chemically bonded together, we can separate them using physical changes in the school. We can separate them using physical change, and those are the kind of like techniques we use to separate things that are not chemically bonded together. And that's what we are going to go into it now. Separation techniques. Separation techniques, as I said, it's kind of like confusing if you don't have solid background on that chemistry. But if you're still having difficulty in it, don't conclude that you're not understanding chemistry because it's actually at the first page and you're struggling with it. Jesus Christ. This first page and I'm suffering. You understand? So you can conclude that chemistry is hard. Unless maybe if you guys did the experiment in your school and you're seeing it vividly, maybe you will find it a bit easier grabbing. But if you're reading in a textbook, you have it difficult. Yeah, I remember that time I have to leave this thing and go and study other things. I was like, this topic is not my mate. But last, I was like, okay, let me go back and since I'm done with chemistry, let me go back and check this senior guy. I went there and I found it very easy. I was even thinking of removing tearing the page and just burn it because I don't need them again. Right? So feel free to have problem with these idiot things here. So let's go there. Sieving. This is the first one we have here. Sieving. So what's sieving? So sieving is actually the method you use to separate like something that is powdery and something that is a bigger in size like stone. This you use it in flour. For example, your mom wants to kind of like sieve. Yeah, you are used to the word sieving, right? Yeah, this thing is actually easy. For sieving, it's cool. Sieving is not something hard. But there are some things we actually kind of like consider when we use sieving method to separate it. One thing I want you to understand is that those things must be solid. Both of them must be solid. So you don't can't go and be sieving the gari you already suck. No, you're wasting your time, guy. You don't do that. You sieve flour, a solid thing. Both of them are solid. But they must be of different size. Different size, please. This is very, very important. Different, different, different in size, right? Uh, that's what you need to understand about it. And that's what they're asking. Anytime that you see question on CV, maybe they'll say which kind of like principle you use in saving. Yeah, has to be what two things of different in size. So if they are different, the smaller ones will pass through the saving pore, while the bigger ones will not be able to pass and they will remain there. So after you finish, you just pour them out and fetch another one, continue. Yeah, that's how you do it. Very easy, no waste of time. The next one, magnetism. Magnet. Magnetic, right? Let's go with it like that. So what's magnet? Magnet is something everybody knows it. I don't need to waste time on it. And we use it also in two or more. Yeah, remember this thing can be two or more, but our problem is that the ones that we need or the ones that we want to save out should be uh, bigger than the ones that want to pour into it, right? So for magnets, like there are some solids that are actually magnetic in nature, while there are others that are not magnetic in nature. For example, iron and copper. Iron and copper. Iron and copper. So iron is actually magnetic in nature, but copper is also a metal. It's solid, but it's not magnetic in nature. So if I have a mixture of iron and copper, like pieces of them, and they were they were um, kind of like mixed accidentally inside a bag, and I want to use, maybe I will just want to use copper, right? Want to use copper and do something, and the iron are there messing up with everything. I can't just go there and start picking iron one after the other. Yeah, picking is also one of the separation techniques, but yeah, it's kind of stressful. So what we use is that we use something that will pick all the iron and leave the copper. And that thing is magnet. And magnet work with the principle that one of them has to be magnetic in nature, while the other one is not magnetic, right? If both of them are magnetic, the magnet will carry both of them, so you can't make use of it. But if we are lucky that one is iron, one the other one is copper, so one is magnetic, while the other is not magnetic, we can pick out the iron and leave the copper. So it works with the principle that one is magnetic and the other is non-magnetic. Like it? Cool. So that's all for magnet. This actually physics is very, very cool. Nothing hard there. So the next one is sublimation. Sublimation, yeah. What's sublimation? We already discussed it here, right? Solids changing from something changing from solid to gas directly. Hmm? So if you have solid things, like you have bunch of things there, um, there is luckily we have iodine inside it. So and this iodine is actually diatomic, so we always put it like this, right? So this iodine, we want to remove it. We don't want it inside, maybe. So what we're going to do, let's say a, I have some metal and iodine is inside it, and I want to remove iodine from it. I don't want to make use of iodine. Well, let me take example. Let's say, okay, we have iodine and sand. I'm actually looking for best example to work with it, right? So let's say we have iodine and sand. They are all mixed together, right? And I want to make use of iodine, not the sand. So what I can do is I can put it on fire, and the iodine will just evaporate, right? Just evaporate. It will not turn liquid. It will not turn liquid and mess up with the sand, right? It will just evaporate. And maybe I'll use something to catch it up, right? It's evaporating to a tube like this, right? That's some chemical reaction experiment. You see something like you put in client or that. It's just to catch it up and put it in one place. So after you finish and they finish sublimating, then you can remove and you'll be like, this is perfectly sand, there's no any iodine inside, and this is my iodine. Very easy to do it, just heating it. So that's iodine. So sublimation. And one thing I want you to remember is that when you want to apply sublimation, because ammonium chloride and even this iodine, they are kind of like really kind of soluble. Like ammonium chloride. This is kind of like non-polar, but for ammonium chloride, it dissolves in water. So if you were given a equation that involves ammonium chloride, don't add water first. First, sublime it and remove the ammonium chloride or remove the iodine there before you add water. Then continue with the rest of the techniques you can use to remove other things here. We'll see them. So this one works in the principle of sublimation, right? When one compound can sublime where one compound can sublime. Okay, now the next thing, decantation. 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 Okay. So decantation is like, for example, you have water and there is sand inside it. Let's say you went to your village and you follow your maybe your grandmother, you went on fresh water in the river or stream, and you brought them back home, and you find out that almost half of the water is actually sand because we drink a lot of this here. So how do you separate it? You can see, you remember most of the time if you are doing it, you actually carry the head of maybe your tube, right? Your bucket, right? The sand will settle at the bottom there, right? And the water will be here. So if you carry it, you are pouring it, it will be coming down, right? To the time that you reach a point where it is the sand that remain there, while almost all of the water, the clean water, have already passed down there. So this is actually a simple way of decantation. In the library, you can use like a glass and block it and do it gradually to remove it. So this one, it works with when you have something forming layers, right? Like one is at the bottom while one is at the top here. So when this thing is at the bottom, while this one is the ones at the top. So always remember this one forms layer. So if it forms layer, you can easily remove the ones on the top and leave the ones on the bottom, right? So that's decantation. So when the mixture forms layer, right? So when the mixture forms layer, you can use decantation for it. Let's go to the next one without waste of time. Filtration. Filtration. Okay, what's filtration? So filtration is used for like filter paper. Yeah, you're used to the term filter paper. You're used to that paper in your library, right? So filtration is used to separate suspension from a solution. Suspension as well, you have to study solubility, deeper chemistry. You have a good understanding of what I'm saying with it. But for now, we'll just go into it, right? Suspension is like a chalk, right? For example, if you put chalk inside water, right? The chalk didn't dissolve. Like if you like, take example, if you put salt inside water, the salt will dissolve it, and you will be like, if you can carry it to someone and say, "This is a pure water," and he'll be like, "Okay, thank you." But how about if you carry chalk and put it inside water and carry it to your uncle and say, "Uncle, this is pure water I got for you." Your uncle, everybody will sense that this is not like you are seeing the chalk, right? It doesn't dissolve. So that's suspension. You understand? So that's the difference between the ones that is soluble and the ones that is insoluble, right? There are insoluble ones that will just rest on the bottom, like you can use decantation. Like let's say the sand, they're insoluble and they just rest, they form a layer on the bottom. While there are the ones that will not form layer, they will just scatter everywhere and mess up with everything. That's suspension. Like dirty water like this. Everything's like, yeah. So just remember suspension here. When you form suspension, for example, chalk in water, right? Chalk powder, right? Powder, not just chalk, right? Chalk powder in water. So you form suspension. So when you want to do it, you form filter paper. Filter paper is just like a sieving, but this one, now I say this one, both of them are solid, but this one of them should be kind of like solid form. Like the other one is actually a suspension, not really solid, while the other one is kind of like liquid, as the water or any solvent like that. So if you want to filter it, use filtering paper, which is very, very thin, right? So if you put them inside, you leave it for a long period of time. See, most of this experiment, if we do it, we allowed it to stay for a day, right? So the next day you come and see your pure water and your suspension. That's your chalk on one side. So that's filtration for you. Cool. So you should know that it's actually insoluble, right? It does not dissolve it. So the next one, centrifugation. Centrifugation. This is physics. Centrifugation. Centrifugal, centripetal. What's centripetal? I used to know centripetal as the force, like just like gravity. It's just gravity. So it's making things to fall towards the earth. That's centripetal. But centrifugal is the opposite, pushing it down out. So if you wind actually a rope like this, centrifugal and centripetal are actually balancing. So once let's say the centrifugal pushing it out is more than the centripetal, the rope will cut. You understand, right? There's a balance between those guys when you're forming these things. So centrifugal force is any force that when during rotation is trying to push things away, right? So uh that's the principle we're using here. If you know centrifugal in physics, I think you find it easy here. So when you're rotating it, when you're actually rotating it, there are some that will go further away, there are some that will not go further away, there are some that will come away, depending on the size of the thing, right? Right? So that's what it is. That's centrifugal. And it's very, very common in like hospital for separating blood contents, right? The plasma, the red blood cells, and even the white blood cells and the platelets. We use this centrifugation to separate them, right? You see your plasma at the top, the white blood cells and the platelets in the middle, while the red blood cells, they are the kind of like bigger ones, right? You see them at the bottom there. So that's it. So uh, so you can see, you can remember speed of rotation, right? Speed of rotation, speed of rotation, rotation. That's to do with rotation, speed of rotation. That's centrifugation. Just know the time, you're fine with it. The next one is flotation. Flotation. You know what? When you actually uh, producing metals anyhow, metals don't, you don't really find metals in nature just sitting down like that. Most of them they are in their active form with other compounds. For example, like sodium, most of the times you find it with chlorine, sodium chloride. Like zinc, most of the time you find it with either zinc sulfide, right? Or even zinc oxide. This one you can also find them most of the time with carbonite, right? So the thing is that you don't kind of like see metal standing on its own. You know, we say it's reactive, so they don't just stand on their own. So during extraction of metal, you actually find metal in their kind of like ore form. For you to purify them and remove the metal, you need this flotation. So that's it. That's all we can talk about this, right? If you go to non-metals and their compounds, all of those, oh, there are plenty, guys. I can't focus to bring those names out of my head. So they are based on ore, right? Or of metals, right? Or of metal, right? So it's actually extraction of metal from their ore, right? Let's use it like this. It's very good. Extraction of metals from their ore, right? From their ore. Is it there? Yeah. Okay. Next thing. Evaporation. 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 We are all used to this one. Evaporation is just heating something to get this guy. You see it? Evaporation is heating something in liquid form to get gas, right? Why do we heat things to get the gas? So there are some compounds that if you put them inside water or put them in some solvent, they dissolve it, just like sodium chloride. Sodium chloride will dissolve, and you will not see the sodium chloride. So if you want to get back your sodium chloride, you have to evaporate. Because if it dissolve, like you mistakenly pour sodium chloride inside water, and you were like, Jesus Christ, I've already lost all of my sodium chloride because yeah, you can't see them again. You can't pick them right? Just like sand, you can't get them back. So for sodium chloride, different. You can't get them back. So what you need is just to evaporate the water. And the principle behind that one is that sodium chloride do not decompose on heat. They don't decompose on heating. They don't decompose. They don't decompose, right? I think I should rate it here. They do not decompose on heating, right? So to know whether a compound can decompose on heating or it does not decompose on heating also require your knowledge of higher parts of chemistry, right? So you can go with it. Okay. Uh, so that's it. I think we're used to the experiment of putting water, stirring it inside water, and putting sodium chloride inside water, stirring it, making it dissolve, and also put it on fire, evaporate the water, and get back the same amount of sodium chloride you put inside. So that's it. That's what you get from that place. Let's go to the next one. Crystallization. Crystallization. Okay. When we are using evaporation for those that do not decompose on heating. What do we use then for those that do not that decompose on heating? When this one do not decompose on heating, we easily use evaporation. While the ones that they decompose on heating, what do you use? Have you ever think of since they say salt, if you put it inside water and you evaporate it, you get back your salt, right? Have you ever think of putting yes, sugar inside water and evaporate it? Guy, you miss your sugar. You're not going to get back your sugar because you need crystallization, not evaporation. Sugar actually decomposes on heating, right? There are a lot of chemicals that if you're heating them, they decompose on heating. So you don't need evaporation. You don't need to evaporate them. There is crystallization that works for it. Crystallization is like forming crystals of that thing, right? Let's say this actually the solution, and let's say there is my sugar there, right? This is actually solubility topic, right? If you have knowledge on solubility, you flow with this thing. So what happens is that there is what we call saturation, where the thing cannot like dissolve anything. Like you continue putting sugar to this thing to a point that if you put another sugar, the sugar will remain there as sugar, it will not dissolve it. So that's saturation. So that's the point we want to reach when we have our sugar here. So what we used to do is actually heat it small to evaporate the water. So when we heat it, maybe it turns like this. So the sugar will be concentrated, like it will be saturated here, right? So if it's saturated, it's already warm, right? Saturated. And solubility of anything on a liquid depends on temperature. So when you are changing temperature, the solubility curve changes, right? This is actually topic on solubility, I see. So when you remove the heat, you're not heating it again. So as the thing is becoming cooler, the solubility is kind of like changing. So it's changing from the amount that it can hold plenty to amount that it can hold only small. So when it reach the amount that it can hold only small, so those that are already dissolved there is no seat for them. So they have to go out as crystals, right? So that's how we use it. That's a good explanation for crystallization. There are other parts of crystallization, fractional crystallization. You can put F there, right? I want to discuss them at once because there's no time for it. So fractional crystallization is when you want to remove two or more things from a solution, right? Two or more things that decompose on heating from a solution. And what you do is that, the solubility curve, like of different compounds, is varies, right? So let's say I have two things there. Let's say I have sugar. Let's say I have sugar. Sugar is more common than drugs, right? Let's say I have sugar and drug, and some of them are actually drug, right? Don't have color for it. Let's manage this, and we have some drug here. So when we kind of like do the same thing, it is small, let up like most of them get saturated. So when we are kind of like cooling it, when we're cooling it, there's a temperature that when sugar reach, it is already saturated at that temperature. But maybe the drugs is not yet saturated. Get it? So when you reach for sugar will form crystal first, and you can remove your sugar first, and maybe later you form your drug. And maybe if you have another another thing, let's say like ammonium hydroxide. If you have something like ammonium hydroxide, maybe if you remove this one, then later on this one also will form its own, and you remove it. That's how we do it. That's fractional crystallization. You like it? So that's good. Whoa, shit. Okay. So the next thing, precipitation. Wow, all these things are plenty. Precipitation, I got to be fast, right? Precipitation. And I think my marker is giving me warning here. Precipitation. Okay. Precipitation reaction, if you know, is actually a reaction between two aqueous solutions to form one insoluble salt. Two aqueous salts, dissolving salt from one insoluble salt, right? So that is precipitation. So if you want to remove something, when you react, when you react one thing and another one to form an insoluble one. So when you form it, you can easily remove it because most of the time we can easily remove insoluble things from soluble ones there. And this is very, very good principle of all of these tests in chemistry, right? Tests of this, tests of this. So you were actually targeting to form an insoluble one because we can easily detect it, right? Based on the color and everything of it. So that's it. That's it for precipitation. There's nothing much on it. You have to go and know the reactions there. The next one is distillation. I got to be fast. Distillation. Distillation. Okay, now, how about if we want to remove solvent from another solvent? Let's say we want to remove kerosene from petrol, right? Kerosene and petrol, they all dissolve each other, right? Kerosene and petrol. What we use is that we actually target their boiling point, right? Which one boil first? You know, if something is boiling, it will be evaporating. So if it is boiling, it's evaporating, we can be trapping it. And maybe the next one, if it is boiling and start evaporating, we'll keep that one aside and start trapping this one. That's how we used to do it. It's quite easy. And it's common in a refinery, right? All of those petrol, gasoline, there's gas oil, kerosene, diesel, all of those guys are actually working the principle of fractional distillation in that you're using just the boiling point. That's the biggest thing you just need to know, right? The boiling point, right? You're just like in the targeting the boiling point. So when you have two soluble solvents that have different boiling points, you use distillation for it. And that's cool. For the fractional distillation, is like you want to remove two or more from a solvent. But for simple distillation, you just want to remove one from a solution. Two solutions, you just want to remove one. So when you're just heating it, you just finish removing the other one. That's all. So that's simple distillation. But if you have to do plenty of them, we call fractional distillation because you have to form some fractions, layers of it. So the next one is separating formula. So this one, the solvent are miscible, right? They dissolve each other, right? You remember I say kerosene and petrol, they actually dissolve each other, right? So this next big guy here, so this separating funnel, it does work on the ones that are immiscible. So when you have like kerosene and water, if you put kerosene and water, guy, they don't dissolve each other. Kerosene will stay in one place and water will be staying in another place. So you don't go and be disturbing yourself with boiling it and all that. You just need separating funnel and just separate them. I don't know how this separating funnel look like, how funny it is. I don't know, sure. But that's what you use. The next one is chromatography, right? Chromatography. Chromatography. I think you're used to the word chroma. I've already discussed this in every biology video that is actually had to do with color, right? Chrome, right? It has to do with colors. So this principle work with the principle of colors, right? But the principle of color is like different in this chromatography, like instrument, the paper chromatography depends on the one they produce you're using. If the paper chromatography put it inside food, so it depends on the colors. So the colors will be moving at different rates. So if you put it inside food, some colors will migrate faster than the others, right? So it will form different rates of migration. So you have to remember something of color, and you also have to remember something of migration, right? Or movement. It's cool for you now. The next thing is that we're going to discuss is separating salt, sand, and sodium chloride. Salt, sand, and sodium, ammonium chloride. Sorry. So this question, you always see it, right? They say sand, salt, sodium chloride instead of all of these things. They used to ask it. So how do you separate these things? Well, we have sand, we have salt, and we have NH4Cl, right? First thing if you are giving equation, start checking the one that's sublime, because we know it's the one we first remove, right? Because we say we don't add water for it, we just remove it directly. So you check this one. This guy is sublime, right? So first thing you're going to do is to sublime. That's sublimation. So what's the next thing? So if we sublime this thing, we are left with what? Only salt, sand, and what? And salt. These are solid sand and solid sand, right? And you know that salt, sodium chloride, table salt, right? It dissolves in water. So, and we cannot go and be heating it, because if we are heating it, we're just making no sense, because it does not decompose, it just stay there for a long time, it just melt. And no, we can't do anything like heating. It doesn't make sense. So what we do is that we add water to it, because and this thing we can filter out sand and leave sodium chloride solution, right? You can filter out sand and leave sodium chloride solution. So what you do is to add water to dissolve this sodium chloride. The sodium chloride as the salt will be as if it is just a liquid. So you add water. If you add water, you have sand and solution and salt solution. Let me use it like that. Salt solution, right? So when you do it, now you now filtered out the sand, because sand is insoluble. So you filtered out the sand. If you filtered out the sand, you're left with what? The salt solution. You write it here. You're left with the salt solution. Right? So the salt solution, what do you use to separate salt solution? Salt and this thing is actually evaporation. Most of the time the equation will stop here. But if they go further, you know that you need to evaporate. Guys. You need to evaporate it, so that all of the water will go and you're left with only what? Salt. So you can see from this place, we already removed sodium chloride, and in this place we're able to filter off sand, and in this place we're able to filter off our salt, right, out. So that's how you can be answering question on this. So before you answer this kind of question, you need to understand very well everything about this is, and you also need to understand things about the chemicals you're giving. Is it soluble? It is insoluble. Does it sublime? Does not it sublime? All of this is. That's why you need to know deeper chemistry before you flow with this topic. Okay, that's it. As we're running out of markers here, we have impurity to discuss, tests for impurity and purifications, which are kind of like discussing topics, so I think I can flow with it. So purity, what's purity? Purity is just, okay, a bit mixture. Like you have sodium chloride, this is your salt. But sometimes it's not coming just real sodium chloride 100%. You have other things that will be added to it, like magnesium chloride, right? And other impurity we call them, like they are different from that sodium chloride, but maybe they are very, very small amounts, right? It depends on how purity it is. If it is very, very impure, then the amount of the impurity is high. Or if it is kind of like really, really pure, the impurity is just very small because nothing is perfect in this world. So that's impurity. So like presence of different is actually mixture, right? But there is one that is predominant for it. While the other ones are just small part of it. I contribute to it, right? So that's impurity. So now what's the test of impurity? How do we test and say, okay, this thing is actually impure or this thing is pure? Because in medicine, pharmaceutical industry, you use a lot of this to test your drug. Drug has to be pure. They have to be pure because you don't produce drug and have a lot of impurity to it and be given to a patient. The drug production of drugs, they really deal with this thing. So how do we test it? Well, you remember we talked about chromatography? We talked that if you actually put it, they move in different rates, right? Different colors. So if that thing is pure, if something is pure, it has only one color. Let's say sodium chloride is just white. You have other things. They'll maintain their color. So if you actually put a paper chromatography or any chromatography, you put it inside that substance you want to measure, they move to the same position, right? They migrate at the same rate to the same position. So if they still stop, make a spot at the same position, you will conclude that actually that is pure. But if it forms different layers, like the migration is different, you can conclude that actually that is impure. You get it? That's one way to do it. So you can test it, impurity test using chromatography. I can write it. While the other test is actually based on their boiling points and their melting point. Now, this is very, very important because both in physics and chemistry, they used to ask it, so I need to figure it out. So you use boiling points and melting points to test whether something is pure and is impure. Pure substance always boils at a specific temperature, not really specific, in a very narrow specific temperature. Let's say water. Water used to boil at 100 degrees Celsius, right? So maybe it was, you can even discover it's boiling at 99 degrees Celsius, right? That one is not the same. But how about your water boiling? You're boiling water and it actually boils to like 100 and let's say 115 or 120 degrees Celsius. Gosh, almost this thing is really bad. This thing has to be impure, right? For example, if you put sodium chloride inside water, it really makes it boil like this. The thing will start boiling from 100 degrees Celsius. You see the thing still they continue to boil, and the temperature keep increasing, right? And you even reach that level. So that's it. So we use boiling point to conclude whether something is impure or impure. Boiling point and melting point here. So let me talk a little about it. So I have a bit mnemonics to kind of like figure out that thing out, and it's quite easy. When I'm doing it, I use boiling point and melting. I just want to know whether it increase or decrease it, right? The boiling point or melting point, right? Uh, I guess this is not really relevant as I'm rolling out of this. If we go to topic in physics, I'm going to talk on this, most especially boiling and melting in impurity, and as well in terms of pressure. I will do video on those things. So this will not make or allow us to do it. And as well, you can calm down and grab these things all and have fun with it. But I guess let me see, guess something. Some mnemonics is cool from some guys. Some don't like it. So if I give you any mnemonics in this video or series, if it is not comfortable for you, don't disturb yourself. Sometimes mnemonic doesn't work for anybody. Like it doesn't work for people, everybody. So just try your best, and if it doesn't work for you, you leave it go and try to make a good understanding for it. So I try to make any money from some of these things and kind of like make it easier to recall it and to practice it. Okay. Uh, but first, I will kind of like eliminate some things that I'm not making use of, like this. All of these physics things, I'm not working with it. Magnetic and even centrifugation, I'm not going to involve them inside, right? Even precipitation, I'm not going to involve things inside it, right? So you should know the ones I'm not involving inside it, right? Yeah. Okay, let's go into it. So, and the way I do it is that I arrange these things. This is where the things start, right? Stop. So I arrange these things alphabetically, right? So alphabetically, you meet A, B, C. You meet C, right? Or you meet no, I'm not using centrifugation. You meet crystallization, chromatography. C H before C R, right? H comes before R, right? If C are first, right. So chromatography, you got it first. Chromatography, I'm just writing down. Then next, you need crystallization. Are you following? This thing don't want to get this mnemonic out, but we'll fish it out, man. ABC, then D, right? Like you have decantation and distillation. E comes before I. We start with decantation and distillation. Distillation. When we go to the evaporation, evaporation, EF, flotation, flotation, filtration. So filtration, I come before L. So filtration, you can complete the names, right? I'm trying to manage these things here. Flotation, right? Okay, and continue to like PQR S. Yeah, we can get S, right? I think what are we left with? We're left with separating funnel and sublimation, right? We're left with sublimation and separating funnel. I'm not putting sieving because sieving is easy for everybody. So sublimation and separating funnel. Yeah, we start with this one for sublimation. Sublimation is also easy because it's just sublime. I'm not using it, right? So separating funnel. Let's say separating funnel, right? Okay, let's go. Put it like this. Anything I forget? 1, 2, 3, 4, 5, 6, 7, 8. I forget it. If I mention them, if anything I forget, I will bring them out, right? I use the fucking mnemonic. Uh, it's not really cool, but at least if you can remember it, it's kind of good, right? Moko, de, Moko, Decla. You can leave it like that. Bonus, Orin. Moko, Decla, bonus, Orin, right? This Moko is the same thing. Dec, la, bo, no, or I am. That's all. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yeah. So this Moko is actually like movements of colors, right? I'm not gonna write it all. You can remember that one. Has to do with movement of colors, right? Those are chromatography. You remember chromo is color. Crystallization is decompose. It decompose on heating, right? Decompose on heating. You can remember it. Isn't that one? This decantation, it forms layer, ly, right? Forms layers, right? And bo, bonus. Hey, bonus here. Bo, boiling, right? That distillation. Remember boiling? Those I'm actually removing the key important words. You can, if you remember it with them, you're cool with it, right? Evaporation, the no decompose, right? Do not decompose, right? No decompose. Anyhow, it's just a mnemonic, must not be fine. So filtration, that's the last S here, is actually suspension. You can remember suspension, you're cool with it. Suspension and flotation, OR, that's O, you can remember O of metal. And the last one is immiscible, immiscible, right? Immiscible. So immiscible, that's when you want to separate water and petrol. Remember when you divide it, remove them. So they're actually immiscible. So this a bit mnemonics to help that if you're too confused to be going around, like you learn it, you forget, you learn it, you forget, you can just learn the mnemonics. And I believe it's going to be helpful. And with this, I'm tired and we come to the end of this class. Thank you.